Hello students, once again welcome to the LJ Institute of Engineering and Technology. Let's start with the course Mathematics 1 and same chapter matrices. Today's topic is diagonalization of matrix. As I told in this lecture, we need compulsory eigenvalues and eigenvectors. So if you didn't practice the DIY and before starting this video, you should practice that examples, otherwise this chapter will be difficult for you. This topic is very difficult for you, okay, without the concept of eigenvalues and vector. Let's start with the diagonalization. Let capital A be a square matrix of order n, then matrix capital A is said to be diagonalizable if there exists a non-singular matrix. Non-singular, that means non-singular, that is invertible matrix capital P, such that this P inverse AP is equal to D, and here this D, matrix D, is your diagonal matrix, and that matrix P is called model matrix. Okay, so we need to find here matrix P, which is called model matrix, and this P is formed by writing all the eigenvector column wise. Okay, so compulsory we need eigenvectors. Okay, and n cross n matrix is diagonalizable if and only if it has n linearly independent eigenvectors. That means if matrix is of order 3 cross 3, then we need 3 eigenvectors. Okay, we cannot repeat the same linearly independent. That means all the eigenvalues are in the eigenvectors are independent to each other, not dependent on any other vector. Okay, if matrix is 2 cross 2, then we need 2 linearly independent eigenvectors. Okay, same way if matrix is 4 cross 4, then we need 4 eigenvectors. Now what are the working rule for the diagonalization of square matrix? So one, find eigenvalues of matrix. Second, find eigenvectors corresponding to each eigenvalues. Find model matrix P by writing the eigenvectors, these eigenvectors which we find here, eigenvectors as its column vectors. So we'll get matrix P. Then find P inverse. Then find P inverse. Then multiply P inverse AP. Means P inverse, which is obtained from here. A is given matrix and P is model matrix. Multiplying these 3 matrices, we will get matrix D, which is our diagonal matrix, and this is nothing but eigenvalues as its diagonal element. D is diagonal matrix, and in diagonal entries are nothing but its eigenvalues. Okay, we will check. Now we have one example so you can understand better. So let's start with the example. Find matrix P that diagonalize A and determine P inverse AP for the matrix capital A is equal to this. Now matrix A is given, so we will find the characteristic equation, then that equation lambda cube minus S1 lambda square plus S2 lambda minus S3 is equal to 0. Then we will find S1, S2, S3, put the value of S1, S2, S3. By factorization, you will get the value of lambda, then we will find eigenvector, and so on. But here you can observe that given matrix is upper triangular matrix, so no need to apply that all the process to find eigenvalues. For vector we have to compulsory, but values we can directly write down 2, 3, 3. Okay, so solution matrix capital A, which is upper triangular matrix. So eigenvalues will be the elements of principal diagonal. So eigenvalues of A are 2, 3, 3. Repeated eigenvalues, but we have to write again because 2, 3, 3. We need 3, as I told. 3 cross 2 matrix, then we have 3 eigenvalues and we need 3 eigenvectors, then and only then we can find diagonalization. Okay, so let's start with the I am just taking this example why this repeated because we didn't take in previous lecture, so I am taking here. Okay, so you can understand better, but process will be same. So for lambda is equal to 2, first we will find the eigenvector. Same process, a minus lambda I x is equal to 0. For that we need a minus lambda I. We will put lambda here. So 2 minus 2 0. 3 minus 2 is 1. 3 minus 2 is 1. So we have this and remaining elements are as it is. Now we can make 3 equation. First 0 into x is 0, row and column. So 0 into y 0. So we have minus 2 into z, so minus 2z is equal to 0, first equation. From the second row, we have 0 plus y plus 0z. So y is equal to 0. Third is 0x plus 0y plus z is equal to 0. So we have z is equal to 0. Here you can observe these two equations are same to same. If I am taking minus 2 common and taking on the right side, so z is equal to 0. So out of these three equations, which is obtained from this three row, these two equations are same, so we will ignore, or we will omit any one equation. So we will omit suppose this. So we have only remaining equations are these two. Y is equal to 0 and z is equal to 0. So we will use that basic concept of homogeneous and non-homogeneous linear system. We have two equation. We have three variable. So three variable is equal to 3 minus 2, which is 1. So we have to suppose 1. Now as I told, we will suppose from the bottom, from the z, y, x, like this. These are the bottom, x, y, z. Na? So from z. We cannot suppose z because z has a value 0. So z is 0. We cannot suppose y because y is 0. So we have two values y and z 0 0. So remaining is x. So we will take x is equal to even. That even is any real number. Now after getting this x, y, z, we will write down the capital X is equal to x, y, z column. So x is your t1, y, z is 0 0. If we take t1 common, so we have 1 0 0, and this 1 0 0 is our capital X1, which is our eigen vector corresponding to lambda is equal to 2. Same process, but no need here to use that grammar rule because we can easily find the value of yz, and we have two equation only, not three, because this equation is same as this. So we have to omit. Okay, we have to omit that equation. So we have two equation. 3 variable, 3 minus 2, 1. So we have to suppose one variable, that is one parameter. Okay. Now we will find the eigenvector for lambda is equal to 3. So we have for lambda is equal to 3, a minus lambda I is equal to x is equal to 0. So first write down the value of lambda. We will put. So we have this matrix, and here these two rows are 0, so we have only one equation. Now, as I told, 3 variable, 1 equation, 3 minus 1, 2. We have to suppose 2 variables. Okay, which variable we will start from? So we will start z. Yes, we can suppose, if we suppose z is equal to something like t2. So if we put t2 here, we will get x. So by supposing z, we will get x. But here, what about y? We have to suppose y also because we have two free variable. 3 variable minus 1 equation, that means 3 minus 1 is 2. Compulsory we have to suppose 2 parameters. Okay, 3 variables. So y is equal to t3. So now let's start. This is the, after we cancel out the minus. So let y is equal to t2, z is equal to t3. You can take this also, no tension. Okay. Now t2 t3 belongs to r. Now put the value of zt3 here. You will get x is equal to minus 2z is equal to minus 2 T3. By writing column wise, we have x, y, z is equal to this. Now we will separate we gonna separate T2 and T3 both parameter. So here 0, T2 0, this one, and T3 0, T3 term. If you don't write this, you can write directly this. If we take T2 outside, so here there is no T2, so 0, coefficient of T2 is 1, and this is our 0. If we take T3 outside, so minus 2, T3 is not available, so 0, and the coefficient of T3 is 1, so minus 2, 0, 1. So now we have this capital X2 and this is capital X3 are eigenvector corresponding to lambda is equal to 3. So here you can observe that for 3 is repeated eigenvalue, so we have 2 eigenvectors. This will not happen in each and every example, okay? Even though we have only one eigenvalue which is repeated, we can get here only one eigenvector. If we will get one eigenvector from this repeated value and from previous one, so it is not diagonalizable because we need 3 linearly independent eigenvector for 3 by 3 matrix as we are told. But in this example, we have 3 linearly independent eigenvectors. We got 2 from this and 1 from the lambda is equal to 2. So we will find the model matrix capital P. So we have model matrix capital P. We will write the column eigenvector in column wise. So we have first eigenvector. This is first eigenvector for lambda is equal to 2, and these are the 2 eigenvector for lambda is equal to 3. Now we will find P inverse. What is the process to find P inverse? By Gauss Jordan. So P I3 P, like A I3 A. So value of P is this. I3, that means 3 by 3 identity matrix, and this P as it is. Now we have to reduce this matrix to identity matrix, and according to this will be our inverse of P. So we have to make that identity matrix 1 0 1 0 1. So 1 is ready, 0 is ready, just we have to make 0 here. So operation will be R1 plus 3 R1 plus 2 R3, R1 plus 2 R3. So this will be 0 and this will become 2. Okay, by applying this operation on first floor entire row. So this is our I3 and this is our P inverse. Okay, so we have I3 P inverse A, and this P inverse is equal to, we have this. So P inverse is this. After getting P inverse, we will write down D is equal to P inverse AP as I told. Okay, so before starting further, I am just repeating again whole process. First find eigenvalue. Then for each eigenvalue, find eigenvectors. Then write down that eigenvectors column wise, we will get model matrix P. After getting model matrix P, find the P inverse. After getting P inverse, write down the formula for diagonalization D is equal to P inverse AP. Now write down the value of P inverse is this. A, that means original matrix, and P, that means model matrix. Now by multiplying these 3 from this side, first we multiply these 2 matrix, we will get one answer. Then multiply this matrix with new matrix, this matrix, and we will get final answer D. And this D is always diagonal matrix with original eigenvalues 2 3 3 eigenvalues, that means in diagonal entry 2 3 3. No need to check this and no need to multiply this in this order. But if you want to check that sir is telling right or not, you can verify by pen and paper. Okay, but you have to keep one thing in mind. Our matrix P, that matrix this P, In matrix P, we have written first eigenvector for lambda is equal to 2. That's why this is 2. And rest of two vectors are for lambda is equal to 3, 3. So we have written 3, 3. But if I am changing the order of eigenvector, if I am writing this vector to here and this vector to here, so our D also will be changed and D will be 3, 2, 3 because this will be from 2 if I am changing and this is 3 and this is 3, so you have to write according to that. So without multiplication you can write D directly D, but you have to keep in your mind that P is formed in which order from the eigenvector. At that order only you have to write the eigenvalues. Okay, so this is the example based on eigenvalue vectors. That's why I am telling before starting this lecture you have to see that. Okay, and these are the important example, that means the IY that you have to solve. I am just giving 3 examples. You have to first write down all this lecture of eigenvalue vector and this lecture, then you can solve this practice example. And if you do practice, then you can understand better for the examination. We know this is the pandemic of corona, but we have the only option which is online study, and to understand online study you have to use pen and paper and practice maximum examples. If you find any query, then you can contact the mathematics faculties. Okay, they will help you by one-to-one teaching. Okay, so thank you for watching this video. Keep watching. We will see you soon with last lecture of this chapter. Thank you very much.